Okay, let's talk a little bit about polyatomic ion nomenclature. So that term nomenclature is just referring to chemical formulas and chemical names of things. So when we're talking about polyatomic ions, we can write them in their chemical formula way, where it's the element symbols with the charge, or we can write the name of it. And so that's something that you need to be able to interconvert between. And so we're going to talk about some systematics and some things that just you have to live with not being systematic. And before we get into that, let's look at what actually a polyatomic ion is. So polyatomic ions are ions that consist of two or more covalently bonded atoms. So this is a little bit more complex than a monatomic ion, and it could be a little confusing because within this ion there's covalent bonds, and then the ion's going to go on to form an ionic compound. Okay, so this is going to form an ionic compound that not only has ionic bonds but also covalent bonds. Whereas if you just have monatomic ions come together and form an ionic compound, you just have an ionic compound, no covalent bonds. Um, and so that part can be a little bit confusing. So these polyatomic ions, they're ions because they have an overall charge, but within them, the atoms that make them up are covalently bonded. So you can see this in lots of different polyatomic ions. Um, and the polyatomic ions just need to have at least two atoms. Now, those atoms can be of the same element or different elements. So the ones I have pictured here, they're all between different elements, okay? But you can have something like the peroxide ion, where you have two oxygens bonded together, but they also have an overall charge, instead of just two oxygens bonded together in neutral. Um, and so just keep in mind, anytime something has an overall charge, it is an ion. Okay, so one key point of the nomenclature of ions is when you name it, it's always going to have the word ion at the end. Okay, whether you're talking about monatomic ions or polyatomic ions. So let's talk a little bit about kind of the systematic of polyatomic ion nomenclature. Okay, so there are some polyatomic ions that do follow a systematic, a regular pattern that can help you predict names of other polyatomic ions more easily, or it can help to where you don't have to like memorize them all or always rely on looking them up. Um, and so this would include oxoanions, or in other words, oxyanions. You can interchange those. Um, and so, as these names suggest, they deal with oxygen. Okay, that's where that beginning part of those names come from. Um, and it's oxoanions, meaning these all have some sort of negative charge. So what happens is oxygen can actually bond to lots of other elements, atoms of lots of other elements, and take on then an overall negative charge and be this stable polyatomic ion, okay, which then will interact with cations. Now, um, the elements that combine with oxygen most often at least form two different oxoanions. Okay, and when I say two different oxoanions, that is, it combines with more than one number of oxygens. Okay, so some things can combine with either one oxygen or two, or either two or three, and so on. Okay, And that's what I'm talking about, two different ones. And then there's some that can combine with four different possible oxygens. And so maybe something can combine with one or two or three or four oxygens, forming four different possibilities. And so that's common for oxoanions to have either two possibilities or three. Okay. And so there's a systematic that encompasses all of that. And that systematic is focused on how many oxygens relative to the other possibilities for that element that's bonding to oxygen. Okay, so if this particular element can combine with two possible numbers of oxygen, it will follow the systematic that I've got in the center, the one that's labeled less oxygen and more oxygen. Okay, and so in this systematic, it's a swapping out of essentially endings of the element name of whatever is attached to oxygen. Okay, and so you take the element name for whatever's attached to oxygen and you kind of get rid of the end of the name and swap it out for either ite ion or ate ion. Okay, and that gives you your names. So for instance, one example of this would be if you have sulfur. If you have sulfur, sulfur could potentially combine with three oxygens and take on an overall -2 charge, and that would be an oxoanion, okay, of sulfur. Another possibility for sulfur is that it can combine with four oxygens, okay, and have that -2 charge. And so those are your two possible combinations of one sulfur atom with oxygen. Okay, so it has two possibilities, and so we would kind of say that one is less oxygen, one is more, right? That's what we cluster that under. And so what we need is to start with sulfur as the name, take off the end of sulfur, and swap it out for ite ion and ate ion. So SO3 2 minus is sulfite ion, okay, whereas SO4 2 minus is sulfate ion. Okay? Now, knowing which elements can combine with two possible oxygens or four possible oxygens can be tricky at first, okay? But where knowing the systematic can be helpful is if you knew one of these, you should be able to figure out the other. So if you knew that SO4 2 minus was sulfate ion, you should say, well, I know if I have the ATE ending and take away one oxygen, then it forms the ITE ending, okay? And so if you knew all of the things that end with ATE, you could always determine what the ITE is just by taking an oxygen away. Or if you knew all the polyatomic ions that have ITE at the end, then you would add an oxygen and it would give you the ATE form. Okay. Now, like I said, there are some oxoanions that can combine in four different ratios with oxygen. And so the most common ones of those are the halogens. And so, for instance, chlorine. Chlorine can combine with 1, 2, 3, or 4 oxygens and then take on an overall negative charge. And so you could have ClO minus, ClO2 minus, ClO3 minus, or ClO4 minus. And those would follow the entire systematic. And what goes in the blank there is the base for chlorine. Okay, so chlorine, you would knock off the last few letters and you would put it in that space. And so ClO minus would be hypochlorite ion. Okay, and then ClO2 minus would be chlorite ion. And ClO3 minus would be chlorate ion. And ClO4 minus would be perchlorate And I know that's all kind of running together. Sorry about that. But hopefully you get the idea there. And so the oxoanions do follow a regular pattern of naming. And so that can help you, if nothing else, to reduce down what you need to memorize or how much stuff you need to look up. Okay. Because you either need to have some of these committed to memory or you need to have a reference that you could use very quickly to look these things up. You also need to be familiar enough with them that you can recognize them when they're part of a compound. Okay. So if you see a compound and somewhere in that you have SO3, then that's probably the sulfite ion combined with some cation. Okay, because then that'll help you when you're doing ionic nomenclature. Because you've got to be able to pull out those ions. You got to be able to pull them apart to understand what makes up that compound so that you can then name it. Okay, so those are the ones that follow a systematic, but then there are several others that I would say are just non-systematic. I mean, you may see some patterns in them, but there's not a definite large number of ions that follow some pattern, for the rest of these. Um, and so all I want to do is just show you a few examples of some really common polyatomic ions that don't really follow a pattern. So there's not other like polyatomics that are like them. Okay. Um, so we have Cn minus, that's cyanide ion. So there's not really others that follow some pattern with that. There might be some other similar ions, but it's not easy to understand their names because you know that one. Okay. And then we have OH minus hydroxide ion and NH4 plus ammonium ion. And so those are just some random polyatomic ions that aren't considered oxoanions. Even though OH, yes, has oxygen in it, that one's not classified as an oxoanion because hydrogen can't bond to more than one oxygen, because hydrogen can only actually bond to one thing. Okay. Um, so those are just some common ones that you do tend to run across quite a bit in introductory and general chemistry. And so those are ones that a lot of times you just need to memorize, or like I said, you need to have a resource that you can quickly look them up if you can't remember the name or if you can't remember the formula. Because remember, you should not only be able to name a given ion, you should be able to go from the name and figure out the chemical formula of it. And also, like I was saying, you need to be familiar enough with them that you can recognize them when they're part of a compound, because you're going to need to be able to pull those compounds apart in order to be able to then name the compound. Uh, so sometimes it's helpful to recognize that there are some systematics to it. It can help make things a little bit quicker for you and minimize the overwhelming nature of nomenclature. Now I've got a couple other slides here that are just resources showing you of, some different lists of polyatomic ions. So these have, even ions that I didn't talk about, but some of them are oxoanions, so they follow the same naming convention as the other oxoanions. And then some are just other random ones. So you can see there are some that don't follow some set systematic that match patterns with others. And I also want to point out, so this resource, this table organizes things by the charge on the ions. So I guess that could be helpful if you're trying to find an ion that has a particular charge. That way it combines with a particular cation in the same ratio or something. But most often when you're trying to utilize a resource to figure out the name of something, this isn't the most convenient way. Okay, but it's okay. If you like this resource, great, you can use that. But there's a lot out there, so you can look up others as well. I did want to point out one other thing here, and this is pretty common when you look up tables of polyatomic ions. they won't give you the complete name. And so all they're giving you is the name, without the word ion. Okay, so technically all of these things should have the word ion after them. Okay, so it's nitrate ion, nitrite ion, bicarbonate ion, and so on. So anything that has an overall charge on it should be named as an ion. That way it is very clear that that thing has an overall charge. Okay, now once that combines with some cation, the charges, are considered to cancel and the word ion drops away. But if you're really talking about that ion only, you put the word ion. One other thing, on this table, notice that they have this 1+ ion and ammonium ion. That's really the only polyatomic cation that you run across. I mean, there are more, um, but the other polyatomic cations that exist just aren't commonly used, at least at a lower level of chemistry, unless if you go pretty deep in, you don't really run across other polyatomic cations. Um, so ammonium ion is a really important one. It does come up a lot. And so it's good to be familiar with that one without having to even look it up. Now, like I said, there's lots of resources, and I wanted to show you one other variation of how you can kind of organize this information to be useful to you. And so this resource lays out, a bunch of polyatomic ions. It organizes them like the periodic table. Okay, so it's showing you kind of the upper right-hand corner of the periodic table and listing several polyatomic ions that exist for each of those elements. It actually also includes some monatomic ions along with it for the elements that have these stable monatomic ions. So it's kind of organizing that stuff relative to the periodic table, which sometimes can be convenient just to quickly find things. It also can help you see patterns of how different groups of nonmetals, combine with oxygen, things like that. Again, this resource, like a lot of others, it drops the word ion off of there just for simplicity. But if you're truly naming those things, you should tack the word ion onto the end of it. Okay, unless if it's part of a compound, that's when that part gets dropped off. So again, that's just another resource, but I would encourage you to look for others, find something that makes sense to you, and organize the information that way. Make yourself a resource that you can refer to as needed. And after you refer to these things more and more, eventually you don't have to look everything up. Okay, you want to get to that point where you're not having to look up every single one of these things. Otherwise, it can be difficult to get anything accomplished.